The Frontal Offset Mobile Progressive Deformable Barrier, or NPDB test, simulates a head-on crash with another vehicle travelling at the same speed. The vehicles we're assessing makes contact with an oncoming trolley, which simulates an oncoming vehicle. Both the test vehicle and trolley travel at 50 km per hour, and impact occurs with a 50% overlap on the driver's side of the vehicle. The trolley has a mass of 1,400 kilograms and a crushable aluminium face to simulate the front of the oncoming car. Two adult dummies are seated in the two front seats, a Thor dummy in the driver's seat and a Hybrid 3 50th percentile dummy in the passenger seat. Two child dummies are seated in the second row, representing a 6-year and a 10-year-old. Both child dummies are seated in child restraints appropriate to their age. The full-width frontal test simulates high acceleration crashes, including head-on crashes and collisions with rigid structures. In our test, the vehicle we're assessing travels at 50 km an hour, and the full width of the vehicle front impacts a solid wall with no deformable element. Impact with a solid wall creates the same force as an impact with a vehicle of identical mass and speed. Two small adult female dummies, 5th percentile, are used in this test, one as the driver and one as the rear seat passenger. This test is used to encourage vehicle manufacturers to include enhanced restraints, including seatbelt pre-tensioners and load limiters, and ensure airbag deployment also caters for smaller statured and rear seat occupants. The side impact test simulates two cars colliding at a 90-degree angle, commonly referred to as a T-bone collision. In our test, a 1,400 kilogram trolley, which simulates the striking vehicle, impacts the driver's side of the test vehicle at 60 km per hour. The barrier has a crushable aluminium face to simulate the front of the striking vehicle. An adult dummy is seated in the driver's seat and two child dummies are seated in the second row, representing a 6-year and a 10-year-old. Both child dummies are seated in child restraints appropriate to their age. As part of more stringent test protocols we introduced from 2020, both the mass and speed of the trolley increased, up from 1,300 kilograms and 50 kilometers per hour. Serious and fatal head and neck injuries can occur in side impact crashes where the car is struck on the opposite side to where the driver or passenger is sitting. These injuries can occur as a result of the heads of the occupants striking each other or coming into contact with hard, intruding parts of the vehicle. In our testing, two far-side impact crash tests are conducted to evaluate occupant-to-vehicle and occupant-to-occupant interaction in the side impact and oblique pole tests. These tests evaluate the likely injury to the occupant on the non-struck side of the vehicle and encourage vehicle manufacturers to include features such as centre airbags to reduce excessive movement of the occupants across the vehicle. The oblique pole test simulates a vehicle colliding with a fixed object, such as a tree or pole, at an oblique angle, a common run-off road scenario. In our test, the vehicle we're assessing travels at 32 km per hour and collides at a 75-degree angle with a metal pole, which is aligned with the driver's head. The pole is narrow, resulting in major penetration into the side of the car. Curtain airbags are particularly effective in reducing the chance of serious head injury in this type of crash, as well as in side impacts with higher striking vehicles. Head and neck injuries resulting from rear impact, rear-end crashes are common and can be significant. Our whiplash testing is conducted to assess likely head and neck injury in rear impact crashes. A seat from the test vehicle is mounted to a mobile sled, which is propelled forward to simulate a rear-end crash. These tests are conducted with moderate and high impact severity, or pulse, representing an average acceleration of 4.9 g and 6.4 g. Pedestrians make up a significant proportion of those killed or seriously injured on our roads as a result of a collision with a vehicle. Our testing not only ensures those inside the vehicle are protected, but also looks at how well the design of a vehicle can protect those outside the vehicle. Our pedestrian tests are conducted to estimate the likely head and leg injuries a child or adult pedestrian would sustain. This is done by firing head forms and leg forms at various test locations on the front bumper, bonnet, windscreen and A-pillars of the test vehicle. Pedestrian protection tests are conducted at a speed of 40 km per hour